Hello, everyone. So I'm Duranjali and I'm an associate director of the solution architecture team in WSO2. So I've been with the company for about 9 years now. So previously, I was the head of the security team in WSO2. And before that, I was an engineer in the Internet Access Management product team for 3 years. Okay, so topic is about protecting your innovation with zero trust. So we already talked about innovation, right? We talked about APIs. Now we're going to look at why we need to protect and what zero trust is. Is the enter or no? Okay. So before jumping into zero trust, we need to understand why we have to worry about protection, right? So we'll be talking about APIs. So what APIs are doing is those are exposing business critical data like personally identifiable information, customer information, could be business secrets, and likewise. So ultimately, what we are allowing people to access through the APIs are important data, right? So when we say we innovate something, it mostly means we are going to do something new with the data, maybe a new feature, right? New service. So it all builds down to data. And since those are critical to a business, we have to worry about protecting the APIs which are allowing access to those data. And the important thing is those are not only internal APIs, right? There are external APIs which are published to the outside as well. So we are creating a channel, right? Directly to the data, which an even outside person can now come through. So we come to the question of how to protect that. Okay. So with the increase of APIs, so we have experience in the past few years, right? Everybody are talking about digital transformation, right? Innovation. So there are loads and loads of APIs popping up, right? All are focusing on giving that experience to the developers through APIs. Now, Gartner predicted several years ago, by this year, API attacks will become the most frequent attack vector that will cause security breaches to the organizations. So did that come true? Salt Security did a research taking data in the last 12 months in 2021. And what they realized was API attacks rose 681%, but compared to 321% increase in overall API traffic. So the attacks are even more than the increase of the API traffic. That's what we are experiencing. And we can see that 95% of the respondents to their research said that they had some sort of security incident related to APIs in last year. So it's that serious right now. So what sort of attacks are we talking about here? So these are just a few examples. One is unauthorized access. It could be because of improper authentication or improper authorization. That means we might be identifying who's trying to access, but not properly, not correctly, right? So we might be restricting data to them, but we might be giving more than they want. So attackers are coming through those loopholes, those weaknesses. Then there are injection attacks, for example, SQL injection, where an attacker can put something into the payload. So even though all the authentication, authorization, everything is successful, still an attack can be done. Right. Then, of course, man-in-the-middle attacks, where an attacker will eavesdrop to the communication and try to gather data or manipulate data, and then distributed denial of service. So these are the common attack types, but of course there are more, right? With new APIs coming up, new attack vectors, attack patterns are popping up as well. Now we come to zero trust. So who has have an idea about what zero trust is? some might know. So it means trust no one, right? So this is a shift in how we used to think about security, right? Several years ago, it was about protecting the physical boundary of an organization. So we deploy firewalls and whatnot, and we try to restrict access. Now, if we allow access to something, and when they come inside our organization or network, we then give free access, right? We trust you. You can do anything, right? So that's what we used to do, sort of a thing. But that perimeter, that boundary is no longer there. So a lot of our payloads, lot of our processors are running in the cloud, not in the physical data centers, not in the local network, right? And especially with this COVID pandemic, there was a shift to work from home, right? So a lot of people are now connecting from outside the organization to the services offered by the company. So there's no longer a perimeter. So summarizing what Zero Trust is, National Cybersecurity Center of UK says it's an architectural approach where inherent trust in the network is removed. The network is assumed hostile, and each request is verified based on an access policy. So there are a few keywords here. One is inherent trust is removed. So we don't trust implicitly, right? We have to verify each and every request that comes to the services. And the other one is, here I already covered that. Request is verified based on an access policy. So this summarizes what this Zero Trust is. But this is not a new concept. So this was actually introduced in 2010. But now only we are hearing this in all the conferences everywhere, right? Why? Because of COVID-19 pandemic and because of the work from home culture, this became a necessity. Yeah. Another thing to highlight is a lot of major attacks, they do not happen at the entry point where the attacker comes into the network. They find the weakest link, they come inside, then they try to navigate across the network, right? And try to go to and grab the data they want. That's the ultimate target. So just protecting those entry points is not useful. We have to protect all the services because they will somehow find a way to come inside and then everything will be freely available for them. So Zero Trust ensures all the services verify who's trying to access and what sort of data they're trying to get and that sort of thing. So at a high level, that's what Zero Trust is. Okay, so National Cybersecurity Center has introduced 8 key design principles. I will try to go through these quickly. So the first principle is you have to know your architecture. Everything that resides inside your network, in your organization, you need to know. That includes users, devices, services, and data. So the first step is to do a discovery of the assets you have. Right? Then only you get a picture what sort of things are out there in my network, in my organization. Then you need to do a risk assessment of those. What sort of data those services are offering, how critical those data are for the organization, and likewise. So once you do that, then you have a clear picture what you have to protect. Right? So the next step is to know your user, service, and device identities. So basically, we represent everything, users, service, and devices using identities. So even a service has identity, device, user, all have identities. Right? So for users, we need a centralized user directory with where we assign roles with least privilege. And for devices, again, a device directory. And for services, we can provide certificates to identify. So when a service calls to another service, we can identify by the certificate. Then the third one is we need to continuously assess how users behave and the health of the devices and services. So from which geographic location the user is trying to log in? Is it different than previous access? Right? Regarding the health of devices and services, Are those compliant with organization policies? Right? What's the strength of the access control in the service layer? So these we have to consider when we are thinking about zero trust. Yeah. So the next one is to use policies to authorize requests. We'll need a policy engine to take decisions based on various factors. So factors could be a user's role, again, physical location, authentication factors, that mean how the user logged in. Is it fingerprint? Is it username password? What sort of thing? So these will be taken into account by the need to be taken account by a policy engine and give a permit or deny answer, right? Whether this user can continue. So each service needs to communicate with this policy engine and get that answer before allowing access. Then the fifth one is authenticate and authorize anywhere. So this means using multi-factor authentication, single sign-on, and if it is a service-to-service communication, there's something called mutual TLS and WSO2. I'm going there, right? So token-based authentication, those sort of mechanisms needs to be in place. But of course, security and usability, there's always a conflict, right? So we had to find the balance as well there. That's why enforcing multi-factor authentication is really good security-wise, but it might not be convenient always. So allowing that only when the confidence of the user is degraded, that's the best approach. Right? And depending on the transaction, maybe, for example, if it's a banking application, just viewing the balance, username and password might be enough. But if you want to do a transaction, do a bank transfer, but then we ask for OTP or something like that. So depending on situation, we might have to step up the authentication. Then the sixth one is we need to keep on monitoring the user devices and services, because even we have all the controls in place, still attackers are very capable of bypassing those, right? Tricking those. So we need to keep monitoring how the system is behaving. Then of course, seventh one is what we've been discussing so far, right? Don't trust any network, including your own. So we used to have this concept of we allow HTTPS to the outside world, but when you come inside the network, everything goes through HTTP. Right? Even recently, I get to hear that, but that's not safe anymore. That doesn't work, right? So once an attack comes inside the network, if everything's going over HTTP, they can see everything that's happening. So HTTP is a must, and computers are so fast today, so you don't have to worry a lot about performance, right? It's not that much, unless you're doing a really mission critical thing, right, in a real time. And of course, we have to choose services designed for zero trust. So when we are trying to implement this zero trust architecture, it's not something you can do in one day or a few weeks, even not in 1 year, right? It's a phased approach, right? You have to go little by little. But if we sort of tend to build everything by ourselves, right? API security, everything, if we are going to do that by ourselves, then that's risky, right? Because you might be not doing it correctly. There are experts who have already built stuff. Right? So rather than reinventing the wheel, it's better to use what's available or things that are matured, right? That provides this sort of security. And of course, another key thing is to always favor open standards. That means that it will be future-proof if you opt for open standards rather than going with the proprietary mechanism. For example, if an application wants to call another application, go with a standard that's already available. Then even in future, if things change, even if you develop a new application, a communication will still work, right? Because you are talking in the same language. Okay, so we looked at 8 principles. One tool, one product can't cover all 8, right? That's obvious. It's a huge project when we are transforming to a zero trust architecture. Here, what I want to emphasize is some capabilities of WSO2 that will help with this approach. Okay. it might look a bit too technical, but I won't go very deep there. So this is about request authorization. So I have pointed those principles I talked about here. Authenticate and authorize everywhere. They use policies to authorize requests. So these principles can be achieved from WSO2 API Manager, API Gateway. So what we are doing here is a backend service is there exposing an API, but rather than having it to deal with all the security, we offload part of it to a centralized, what we call as an edge gateway, right? So this edge gateway can enforce authentication, authorization, rate limiting, all of those. So it can authorize both external and internal requests. So again, trust no one, so not even internally. So within the network, local network itself, you can have an internal API gateway that is fronting the internal APIs, right? So when you want to call an internal API, even if you are an internal application, you still need to get a token and go through the whole process. And it supports user role-based authorization. So depending on a role you have, it can reject a request and not allow you to go to the backend service. And it can integrate with policy engine. So use policies to authorize. So I have given two examples. One is OPA and the other one is SACML. So OPA is for the techies, it's REST-based. SACML is XML-based, right? So there are different kinds of such policy engines that can take a decision based on different factors. Right, so we have, so the gateway can cover a part of the security. So the service doesn't have to do all those checks, but still there's a communication happening from the gateway to the backend service, right? So even though that's in the internal network, if we are saying zero trust, we can't make it go over an unprotected mechanism, right? So we need to secure that downstream access as well from the gateway to the service. So one way is to have what we call as mutual TLS. So what it does is only pre-configured services can call this backend service. So we configure in a way that only the API gateway certificate is trusted by the service, no one else. So no one else can communicate with this. And also API gateway can authenticate to this service using username password or again an access token. Right, so we are building the security to this part as well. And it can also pass the identity context using something called JWT, identity structure, set of data that we can pass. So when the app sends the request, API gateway can build this token and sends to the backend service. Now backend service can also do additional authorization checks, depending on the role in the token or attribute of the user, things like that. Okay. Right, so this is a quite big slide. Here I am introducing WSO2 Identity Server into the picture. So WSO2 API Manager can do authentications like username and password. But if you recall, we talked about multi-factor authentication, right, in Zero Trust. If we are going into that, in order to cater that, WSO2 Identity Server comes into the picture. So it's a dedicated product, dedicated identity service that can provide very advanced authentication mechanisms that can cater to zero trust requirements. And we support passwordless authentication as well. So if you know, if you're a Mac user, you can log in using the fingerprint, right? So you can log in to IT server using the same fingerprint using a Mac, because there's something called FIDO protocol that's happening. Then we support adaptive authentication. That means based on the request, based on the environment, or based on the risk, INT server can take different decisions. And it also supports policy-based authorization based on SACML and OPA. So all of these are advanced authentication mechanisms that are needed for zero trust approach. So we introduced identity server and we integrated API gateway to provide that that level of security when we are innovating with APIs. Okay, so finally, this is about security monitoring. Again, the principle is focus your monitoring on users, devices, and services. Here, both identity server and the API manager can easily integrate with analytic servers like Splunk and Elk, and some security event management systems. So they can, for example, identity server can push the authentication and authorization events to the analytics service, and API gateway can publish the logs and metrics and related to API access again to these analytics servers. So we can correlate things there and figure out if someone is trying to do some malicious thing with these requests. Okay, so that's a very brief overview of what Zero Trust is and what identity server of WSO2 and API manager of WSO2 can do to help achieve that. Again, you need a lot of tools to achieve the full picture. So this is a part of Zero Trust that WSO2 can help. Any questions?
Gulati, we actually have a question online.
Yeah.
Okay, this is in relation to the slide 1 or 3 that you presented. Maybe you can go back. The data stays where it is. We just use it for the need we have. Is that correctly understood?
Which slide is it?
Number 1 or 3. I should be 3.
We just use it for the need. Yeah, yeah. So
it was for someone online, Jerry, if I'm pronouncing the name right.
Yeah. So the question is, the data stays where it is. We just use it for the need we have. Is that correctly understood? So it can be that, yes, we might not have to move data because data can be there in the database. But there could be scenarios where we have to fetch data and do manipulation on the data and store somewhere else as well, right? Especially in the streaming sort of scenarios. So both are applicable. I hope you answered the question. Okay.
Thanks, Dr. Banja.